Hello, everybody.
Hola. Good day.
Good day. Good day. It's morning for us here. Pretty early. We're going to try and get the energy up here, but we are working on circuit organization today. So this video is a little bit more practical. You'll see a lot more about how this works when you're in person in front of your systems. But we want to go through a method for keeping track of the wires and going through stuff in an orderly way in order to make sure that you don't miss a connection that you wind up having to chase wires about later.
Especially after you have everything kind of put together, or you have just wire runs that are just busy, and last thing you want to do is dig anything out of there.
Yeah, and we saw in that first video, or like the first video on this topic, where you could get a cabinet that's an absolute mess. And no matter what you do, there is going to be a lot of wire in there. And there's going to be a lot of wire in there on purpose because you don't want to cut any of the cables or wires short. You want to have the ability to rewire things. You don't want to make the run exactly the length that it requires because vibrations, because you may need to rewire it. The worst thing is realizing that you don't have enough wire to make the run and you're going to have to splice something. Bad form.
Yeah.
So you're going to have a lot of extra wire in there, and it's all going to be hidden away in your cable trays. But that also means that you've got to be organized when you're doing it in the first place and tuck things away in an orderly fashion so that you can know that you've made all the connections correctly.
It's a skill. You'll end up making mistakes, but
Yeah.
you try to minimize them as much as possible. But yeah.
Yeah. So what we're going to show you here is going to be one method. It is not the only method,
No.
but I've found that this works for me. It works when you're first starting out. Now, if you find later on that you would like a different sort of methodology, that's fine. Just make sure that you make it a method.
Yeah.
Don't do it haphazardly, and then you'll be fine. So let's go ahead and, why is it not advancing? There we go. So here's the workflow, and I've come up with a little catchphrase here that'll help you remember this. Good common practice, edit in off mode. Something you should do,
Yeah.
right? Don't do it don't do it live.
Don't do it live.
And that goes for everything that we're doing here. You don't do these things when it's plugged into the wall.
That's a very safe practice.
Yeah, do not do this while it's plugged into the wall. But good common practice, edit in off mode. This is how we remember that we do things in this order. Starting with grounds, then moving to commons, power, excitation, inputs, and outputs. So that's how you remember those things in that order.
How'd you end up coming up with that acronym?
A lot of time staring at a board. Like you've got all of these, sort of mnemonic devices. I was just staring at a board. I've got to come up with something. It's like, please remember my dear Aunt Sally.
Yeah.
Yeah, no, I just I put the order that I do things down, and then I was like, how do I get people to remember to do things in this order? And I was like, okay, I guess it's like, the scale on the musical scale or whatever. So I'll come up with something for that.
Kind of like staring at those pictures that they you don't see anything.
Oh, the magic eye things,
Yeah,
the ones that
you get to stare
where
at
you
for a
cross your eyes.
Yeah, there you
I've
go.
never been good at those.
Oh, me neither.
I feel like those actually are there to make people look stupid. Like I think they've got hidden cameras in a lot of them, and they're just like, oh, let's see what this guy looks like with
Yeah.
his eyes crossed and making stupid faces.
That would be funny. We got to bring those back. I don't see those too often anymore.
No, I think
You You used to see them at the mall all the time.
Oh yeah, you did. Yeah, a long time ago. But,
Anyway,
all right, let's get grounded.
yeah.
Let's get grounded. Um, so grounds. We're making the connections to earth ground, and that means that if you've got like a signal ground where all the signal grounds are gathered together, you're making that connection to earth ground once and only once. Grounds can also involve shielding of cables, but it's basically you're making all the connections that actually eventually go to earth ground, do those 1st in their entirety. Now, the reason why we build up using this order is that it actually goes from fewest connections to most connections. Therefore, we don't have a whole lot of wires that are already there standing in our way to try and confuse us as to whether or not we've made a connection.
Right.
So if you make a connection to ground first, that's done. Your system is actually way safer now if it were to actually accidentally be energized.
Right.
So making those ground connections first just makes sense.
Yeah, and the last thing you need is loose ground or something that's
Yeah.
just not grounded properly, and
Yeah.
you're gonna wind up with problems, and then you're gonna have to take things apart, and it's just a lot more work.
Particularly when you're dealing with things like the possibility of ground loop noise when you're dealing with analog signals. It's really important that you make sure that you've done it right. It's real easy to create a ground loop when you think that grounding is just about making sure that everything connects to earth ground, and sometimes you can overdo it, and that's what creates ground loops, right? It's when you make two connections to ground, and then that splits any current that's going to ground around, and that creates a problem in and of itself. So you want to make sure that everything is routed correctly. One connection per item that goes to ground. Don't do two, like shielding of cables. Although there is, like in the cable, there is a conductor on both ends, that needs to only be connected to ground on one side. If you connect both ends, you're going to create a feedback loop through there that will induce current on the very things that it's trying to shield.
Yeah, and when you guys go through this, always make sure you second check your partner's work. I mean, there's nothing wrong with going back through and going, hey, asking for, hey, you mind second checking my work here, just to make sure you got all that done. That way you guys can safely move forward and not have to worry or be concerned that, maybe you missed something, or, you have issues just like we just mentioned.
And the good news is that you don't have to really memorize exactly how the grounds need to work for every single type of thing that you've got in the cabinet. There's going to be sample wiring diagrams for these things on almost all documentation that you find. It's going to tell you exactly how to ground that component. And
that's another very important aspect, right?
Yeah.
Is RTM, right?
Yeah, RTM, RFM. You need to be reading that documentation to make sure that you're using the component correctly. Comments. So comments, you all need to think back to IMO and think about syncing versus sourcing, because commons can be either positive or negative. So when you're syncing, you have a negative common. When you're sourcing, you have a positive common. And that is what you run from that. So you wire up the commons so that you get those right, because usually that's only going to a few terminals on the PLC. So you wire it from the PLC to the relevant bus bar. Pretty simple. If you're running multiple voltages, you might have multiple commons. Or you might have the same common, but you need to run it correctly for how you're setting up your inputs and outputs. So that is the return path essentially to the power supply for every single circuit that you run on there. So, and we'll get more into that when we talk about the actual inputs and outputs.
Yeah. Make sure you ask questions on this if it's still a bit confusing. I know it's been a minute since you guys have been in IMO, but
Yeah.
you know, it's totally fine. I mean, go ahead and ask, and it's better to get it right first time.
Absolutely, absolutely. Then we got power, right? So power is when we make the connections from the power supplies to the relevant bus bars. So you want to connect your main source to the power supply, and you want to connect, and by the way, the main power supply, like the mains to the power supply, includes the ground from the wall. So when you connect that, everything on the negative side of this, the power supply, is grounded to earth ground through the power supply. If you need it's only when you need a separate signal ground that you would then have another ground that's attached separately. Then you connect the power supply to the positive bus bar, plus 24 volts. If you've got another voltage, you would have another bus bar that is 5 volts, 12 volts, whatever it is. So you need to make all of the connections necessary from all of the power supplies. And then the power supply to the 0 volt negative bus.
Yeah, you guys have seen this with all the mech systems we had in IMO.
Yeah.
So if you need to go back and come in the lab and check things out, kind of look over those systems again,
Yeah.
and kind of orient yourself and just kind of go back to your EMI chart and your electrical schematic chart, feel free to come back and reorient yourself.
Yeah, absolutely, absolutely. Excitation. So this is something that you haven't really seen a whole lot of. There is some in the systems that you dealt with in IMO, but like this is an important thing to recognize here, because anytime you're dealing with an input or an output that has 2 wires, that's easy, right? You've got, depending whether it's syncing or sourcing, you've got power going out to that, and then you have it returning on that signal wire that you hook up to the terminal on the input or the output. But when you've got 3 wires or 4 wires, there's something transistor based or there's something relay based, you can have this situation where you need to supply that with an excitation power. Now, excitation is just the word that I use to describe anytime we're running things other than the power to the input and the output or input.
Also means you should be excited about this.
Yeah, you should be excited about this, but it's hard to. It's like 7 something in the morning here.
Right.
But yeah, so when you've got 3 wires, when you've got 4 wires, you really want to look at the documentation that comes with that sensor or actuator and figure out exactly how it's supposed to be wired in as an input or an output. But for instance, on this one, we're running for excitation. You'll see that we have the blue and the brown.
It's brown, black, and then
Brown, black, and blue. Yeah. So so you're running the brown to positive. You're running the blue to negative. So that would be our excitation. And it would already have done the step because the connection is internal into the sensor for the actual black wire, which is our signal wire on this. So when you do this, you make sure you hook up the right wire to the right thing and you send power out, and we actually complete that circuit. That makes it actually a little easier with a 3-wire one when we go to do that, because the remaining wire just goes straight to the terminal, all connections are made, and you're good.
Yep.
So, um, so yeah, excitation. The good news here is now is when we start getting a whole bunch of wires in there.
Yep.
But they're all wires that are leading from the same place and going back to the same place.
Mm-hmm.
They're all coming from the positive bus bar and they're all returning to the negative bus bar. So now we start getting a lot of wires, but they're all basically the same routes. It is possible to daisy chain things, essentially create parallel paths out to things if they're out there. Just don't do it for anything that's an analog signal. If you get too much, like what happens when we do that is we get too much current going through the wires and then that can cause induction. So don't do it with anything where you've got analog signals in there. In fact, in all likelihood, the best practice is always going to be having one wire going out and one wire going back.
Yeah.
Don't daisy chain them all up together. All right,
I/O.
I/O. So this is the last bit of it. This is the part where you need to be tracking things and do it in order. When you set up your terminal blocks should be in order of the inputs and outputs, and you need to make one connection at a time.
And make your life a lot easier.
And make sure you're looking at your tag table at the same time, so that you hook up the right thing to the right terminal. Because otherwise, you know, if you hook up the retract sensor when you should have hooked up the extend sensor, it's not going to work. And you're going to be left there wondering whether it's because you programmed it wrong or
And it happens, you know,
It happens.
especially when you're doing so much wiring and connecting. I mean, you really kind of get in this. You get complacent
Yeah.
as well, you know, just because you're making so many connections, you're cutting wires, and then you get all the, and it can happen. You're human,
Yeah.
and it's just good to go through, and you know that's why it's good and important to have tags on your wires as well.
Yeah. And so, like, this is where you have to keep in mind how each sensor is wired in there. So, for instance, a normal 2-wire sensor, you're going to be running power when it's syncing, or you're going to be running the negative terminal out to it when it's sourcing. And so that's one run, and then you return back to the actual input terminal on the PLC. If you make that whole run there, the PLC, we've already done the connection to the opposite terminal of the power supply through our common. So that works, right? And you're able to make sure that that works each and every time. If you have a 3-wire or a 4-wire one, well, we've handled the excitation separately. So a 3-wire one, you're just running that last remaining wire to the input terminal or output terminal. And for a 4-wire, you're running the same circuit as you would for a 2-wire. Yeah, it's pretty straightforward, but you do it and make sure you make the full connection. You do that whole loop. So if you do this, you repeat it, you do this, you repeat it, you're going to start adding a lot more wires in there. Everything's going to get a lot more confusing if you do it, you know, essentially like you're reading a page.
Systematically,
You just
Top to
start
bottom,
with
left to
the
right.
first input, like on your PLC, the one that you've already put in your tag table. Make sure you follow the tag table. Make sure you follow the wiring that's required of each individual sensor, and it's just going out and coming back. That's all there is to that. So yeah, that's basically the methodology. You're going to get a ton of practice in this.
Yep.
As you start wiring this up. Big things. Keep your tag table handy. Always look up the information on each individual component. And yeah, just follow the method.
Yeah, and work with your team. Don't go on independent ops on your own and start coming up with some newfangled ways to wire things. Like make sure
No. At least try this methodology
Try this method first.
first.
And
Like, it's when you gain experience that you can say, oh, I think this would work better for me.
yeah, and you'll find new ways, and depending on what equipment you're wiring up, there's a lot of nuance there.
This
with,
doesn't necessarily cover everything.
No, there's
like,
so many. Yeah, there's so many.
I would say save things that are more complicated that you don't know where to fit until the end.
Yeah,
Is a good way to do things. If there's something that's like odd, save that to the end.
Yeah.
Then you've got the rest of the system, and you know that you've got the rest of the system done right, and then you can do that, and those wires are then sitting on top of everything else,
Right.
so that you can then work with them.
Yeah. And if you come up with a better acronym, let us know.
You don't like this one, do you?
I don't know. I don't know. I think it's the first rev, is it?
It is the first.
Yeah. So.
I mean, yeah.
It works.
It
For
works.
now.
It works for now.
Yeah.
If you do come up with something better, yeah, that's great. Yeah.
Yeah.
Please remember my dear Aunt Sally. All right. Thank you very much. We'll see you in the next video.
All right.